2.5, using linear models. So we're going to get into working with some word problems here and some data and plotting points and talking about some correlations. So this section, really, we're going to use a lot of technology. So make sure you're pausing your screen and getting the proper notes and writing down what you need to write down as we go through this. And I'll put a couple formulas down that we need, but we're going to talk about making a scatter plot. And a scatter plot is just given a bunch of data. In 2.1, we were given ordered pairs, basically a relation of ordered pairs, and now we're going to be given a relation of ordered pairs and asked to make a scatter plot where you just plot them. And in our problems, the scatter plot's already going to be made for you. You just have to tell me one of 7 things. Here there's 5. Strong negative correlation. Negative correlation is when you would have if you were to draw a line of best fit through it, it drops from left to right, so it goes down. Weak negative correlation is it's not quite forming a line as close together, but you can still tell that it's trending downwards. No correlation has dots all over the place. A weak positive correlation, they go up, but again, they're not very close together. And then a strong positive correlation, they go, again, up from left to right, but they're not as far apart. They're a little bit more close together. So we're going to look at some problems. And I said there were 7. That's because on Delta Math, they also do a perfect negative correlation. And that's when the dots form a perfect line that's going down from left to right. And a strong or perfect positive correlation would be going up from left to right that form a straight line. So we're going to take a look at a couple of examples of correlation, the problems that you're going to do on Delta Math. And again, these are the problems that I'm going to assign you. I'll probably assign you 5 to 8 of them because they're not very difficult. But if you look at this problem right here, okay, the dots are all over the place, but it looks like they're going down. So this would be a weak negative correlation, okay? A weak negative because they're going down, but they're kind of far spread out, okay? So again, weak negative, they're going down, but they're spread out. So we look at the next problem, see how they're all over the place. I couldn't form a line going up or down. So this would be no correlation. Okay. This problem here, again, they're all over the place. So there would be no correlation. This one here, no correlation. They're all over the place. There we go. There's a different one. Okay, so see how these dots are all lined up in a perfect negative slope? They're going down from left to right. So this would be a perfect negative correlation because they're all going down from left to right. Let's do one more. That's a no correlation. This would be a strong positive. It's not perfect because they don't form a straight line, but they're pretty close together and they're definitely rising from left to right. So that would be a strong positive correlation. So you have a few of those problems. Again, they're easy to do real quick. Shouldn't have to spend too much time as long as you know these definitions right here of a scatter plot you're going to be given, and then look at them. What does it form? Does it form a positive slope or a negative slope? Negative, negative, none, because they're all over the place. A positive correlation and a strong positive correlation. The next thing we're going to do is we're going to be asked to write down the set of ordered pairs. So I'm going to give you ordered pairs, and I'm going to ask you to write a line in point or slope intercept form. So we're going to have an answer that looks like this: y equals mx plus b. In order for me to answer this question, I have to find the slope and the y-intercept. Okay, so how do I do that? I'm going to use Desmos. Okay, so again, I would write this chart down, okay, and I'm going to plug all of these into Desmos. So I'm going to go to Desmos, and in Desmos, and I'm going to try to split my screen here so you can see it and what I'm doing here so I can see the table of values. Okay, in Desmos, I need to fill in a blank chart. To get a blank chart, I'm going to hit this plus sign right here. Okay, the table, I'm going to hit the table button. So I have an X1 and a Y1. So I'm going to fill in every ordered pair. Again, the first ordered pair is negative 5, 3. So I would go negative 5, I would go 3. The second ordered pair is negative 4, 2.5, negative 4, and then a 2.5. I'm going to fill this whole table in. Okay. -3. So again, it goes -3, -2, -1, 0, 1, 2, 3, right? Yes, 1, 2, 3. 1, 2, 3. There we go. And then I'm going to put my y values in. So -3, 2.8. You have to make sure that you enter the points correctly. And as you can see, as I'm entering these into Desmos, they are popping up. Sorry, -2 is 3.2. They're popping up and showing me the actual dots right here. So when I plug in -1, I put a 3, 0, 4, 1, 4.2, 2, 4.3, and 3, 4.5. Okay, so I have all these ordered pairs in here now, and I can see from this information that I was given here, I entered them into my blank table. Again, how did I get a blank table? I hit the plus and I go to this table. Okay, so now I want to be able to find the slope and the y-intercept. Well, Desmos does that for us. Okay, so I'm going to put in y1. I have to put y1. You literally just hit the 1. Okay, and then I put the little tilde symbol. The little tilde symbol is right here. Again, in Desmos, if you need to find that symbol through here, you can go to functions and miscellaneous. No, not miscellaneous. Where are you? Let's see. Distance, stats, trig. Hold on. Oh, you got to go to ABC. Sorry. I don't think I can see it right here. ABC. Okay. And then the little symbol's right here. Okay. So I don't need to go to any of those. I just click the keyboard. When I click the keyboard right here, I click on ABC and it will take me, the tilde is right here. Okay, and I'm going to put in the formula for slope intercept form, mx1 plus b. And as I'm doing that, you're going to notice down here that it gives me R2, R, E1. All these things mean something mathematically, but we're really focused on the M and the B. Okay, so if I go back to this problem, I have a slope of 0.25 and a y-intercept of 0.375. We will round every one of our slopes and y-intercepts to the 100th place. So you need 2 decimals there. So as I'm writing these down, okay, again, that formula for Desmos was y1 tilde mx1 plus b. You have to make sure that this subscript, these ones, are the same thing that's inside your table here, okay? Because if you don't have the same value here and here, then it will give you a different answer. So my answer for this would be y equals, what was my m that I got plugging this in, 0.25, so 0.25x, and my y-intercept is plus 3.75. So really, it's just punching a bunch of buttons to get my correct answer, and that's what I'm looking for. Okay, so we're going to go back to Desmos here in a second to do another problem. So let's look at this next example. Okay, it says you research the cost of movie tickets for recent years to look for trends. The table shows your data. Okay, so the key is, this is my x values, this are my y values. We're going to let x equals 0 be year 1995. We're not going to plug in 1995 for x. This is going to be 0. And then how many years after 1995 is 1997? This is going to be a 2. This is going to be 4. This is going to be 6, 8, 10, and 12. Okay, so I need to enter my data into Delta Math. Okay, so again, showing you that. Now I want you to watch what happens. If I enter a new table, see how this says X2, Y2, and I'm going to keep it like this just so you see it. Okay, this says X2, Y2. When I make my line of best fit, this isn't going to work. I'm going to have to change that to Y2 and X2, but we're going to keep that there so I can go ahead and fill in my data. Again, I let 1995 be 0. So that's the year that it started. So 0, and then 2, and then 4, and then 6, and then 8. These are the number of years after 1995, and 12. And then I'm going to fill in my Y values, 4.35, so $4.35, $4.59. In 1999, it was $5.06. In 2001, it was $5.65, $6.03, $6.41, And then in 2007, it was $6.88 for the average cost of a ticket. So now that I have these in here, this is not my answer. Again, I have to go back here and I have to change this to Y2 and X2. And why is it Y2 and X2? Because when I created my new table, bam, it gives me X2, Y2 there. Now, if you created a new table and let's say you X this one out, okay, so that's all I have there, okay? That's all I have. This table is now gone. So all I have is this. If I want to, I can change these subscripts and it will give me the same answer. But again, they have to match. Okay, that's X1, Y1. This has to say X1 and Y1. Okay. Again, it's a matter of just pressing buttons, but you have to make sure that you enter that in there. So we're going to round our answer to the nearest hundredths place. So again, I'm going to get Y equals, okay, from this, come on. From what I got right here, I'm going to get Y equals, I'm going to round it to two places. So I'm looking at the 7 right here. The 7 tells me to move this 1 up to a 2. So it'd be 0.22x plus my y-intercept is 4.26. Okay, so this is the formula I'm going to use. So what is the equation of the line of best fit? Bam, it's very accurate because I rounded it to two places and used decimals or used Desmos. For B, based on your linear model, how much would you expect to pay for a movie ticket in 2025? So this is my X value. But again, I'm letting 1995 equal 0. So how many years since 1995 is 2025? And that would be 30 years. Okay. So to answer B, I'm going to plug in 30 for X. So I would get my calculator out or go to Desmos, okay, and I would put in Y. I would just put in, I don't put in Y equals. I'm just going to put 0.22 parentheses, 0.22 parentheses. I'm plugging in 30 because 2025 is 30 years after 1995. And then I'm going to add my y-intercept to that. So to answer that question, okay, to get that answer right there, where'd you go? No. Oh, that equals plus, that's why. So plus, and it gives me $10.86. So to answer B, again, plugging it into Desmos, B is after 30 years, it would cost on average of $10.86 for a movie ticket. So that's how we can use this data to answer these questions. So you're going to have a couple of questions like this where, again, you've got to enter all that stuff into a blank table. How do you get a blank table on Desmos? You hit the plus, you go to blank table. Okay, and then you've got to enter the formula. What formula do you enter into Desmos? It's always Y1 tilde. That is not a tilde, sorry. Making a mess. Okay, Y1, the little tilde symbol. So Y1 tilde MX1 plus B, and it will tell you what your M is, and it will tell you what your B is like it is over here. Okay, there will be a few problems for delta math for us to do.